Hello everybody, I'm a tutor of physics and mathematics, and today we will talk about one interesting geometric shape called a convex polygon. The convex polygon is a simple polygon that is entirely contained in a closed half plane defined by each of its edges. For example, this one. If the polygon doesn't satisfy this condition, it's called non-convex or concave polygon. For example, this one. We can split this polygon by a line defined by its edges like this. So the polygon is not entirely contained in closed half plane defined by this line. The convex polygon has a very interesting property. The sum of its interior angles adds up to a certain value, which is defined only by number of its vertices. Let's calculate the sum of the interior angles of the polygon with 8 vertices. First of all, let's divide the polygon by all diagonals drawn from the common vertex. As you can see, we obtain 6 triangles. So it's clear that in case of polygon with n vertices, it would be n-2 triangles, and the sum of the interior angles of the polygon equals to the sum of angles of all obtained triangles, because each angle of these triangles is a part of the interior polygon angle. Besides, everybody knows that sum of the angles in triangle is equal to 180 degrees. So if the number of triangles is n-2, then the required sum of the interior angles of the convex polygon is equal to 180 degrees multiplied by n-2. We can obtain the same result using a slightly different approach. Let's connect some point inside of the polygon with all its vertices. Now we have 8 triangles, as much as number of vertices. So in the case of polygon with n vertices, we would have n triangles. And again, the sum of the interior angles of the polygon must be equal to the sum of all angles of these triangles minus 360 degrees that corresponds to the value of central angle inside. Now we just open the brackets and simplify obtained equation. And finally, after taking out the common factor of 180 degrees, we obtain exactly the same equation for the required sum of the interior angles of the polygon. So we've got the answer what is the sum of the interior angles of the convex polygon. But what if we talk about the exterior angles? What is the sum of the exterior angles of the convex polygon? Let's try to answer this question. First of all, we should say that each exterior angle of the convex polygon and corresponding interior angle are complementary. So they add up to 180 degrees. For that reason, each exterior angle of the convex polygon equals 180 degrees minus corresponding interior angle. So to calculate required sum of all exterior angles, we should multiply 180 degrees by n and subtract the sum of all interior angles of the polygon, which equals 180 degrees multiplied by n-2. Here n is the number of vertices in the polygon, and it's the number of its edges as well. After all simplifications, we obtain the following result. Sum of all exterior angles of the convex polygon equals 360 degrees. Interesting. That means that all the exterior angles of the polygon drawn side by side cover exactly the whole plane. To illustrate this fact, let's scale our polygon down to extremely small sizes. Finally, after infinitely large number of steps, we will obtain just the point instead of our polygon, and all the exterior angles will cover the whole plane without empty holes. So now we know what is the sum of the interior and exterior angles of the convex polygon. Remember this lesson. And that's all for today. Thank you for watching and goodbye.